This weekend?
Yeah.
What do you do? Clean up the strange hours.
I'm a dispatcher for Graphic Ambulance Company. Yeah, I work gigs. And like yesterday, I worked 14 and a half hours.
Alright, so guys, let me formalize something that we said a minute ago, and this is a really easy point to miss, but it's gonna become very important pretty soon. What must be true, based on what we've already said earlier about the gradient? What must be true about the gradient in any contour curve, any level curve, actually, let's keep it in X, Y.
If the dog, or the deer.
So, okay, right, you with me? What we were talking about earlier was, if I'm moving on a level curve, or a contour curve, if I'm actually on the surface, that means that I must be moving in a direction orthogonal, and actually just kind of give it away. The dot product must be 0, which must mean that the contour curve itself, or if you push it into the xy plane, the level curve must be how related to the gradient always?
Perpendicular.
They must be perpendicular, they must be orthogonal. There's a really cool picture that freaks people out. Let me ask you this, how would you be orthogonal to, if this was your level curves, if they were circles?
Pointed inward. Going out.
Yeah, it would just be a straight line, right? In fact, later we'll talk a little bit about this in a different way. There'll be radial lines that are just coming straight out along the radius straight out. How does it change if I have, instead of circles, if I have ellipses?
They have to curve.
They do have to curve. And that's what freaks people out.
Well, if it's
Spiral.
And here's a really good picture of it. I'll show you. It's really interesting to figure out the math behind which way should it. Let me remember where it is. Sorry. Oh, it's over here. I think it's this one. Yeah. So I like this because this is what I've been trying to say. Before I get to that point, you can kind of see what I'm talking about at the base of it. But you always have what's going on in the xy plane and the inputs. And you at the same time have what's actually happening on your surface. So if I had a ball that rolled along the inside of this, of course if it was outside, it'd drop. But if it rolled along the inside of this thing, what path would it take? It's got to take this path, which in physics is often known the path of least resistance. Right? Water is always going to flow, and yes, I say the word water as water. Water is always going to flow along a direction that is orthogonal to the contour curve. It's always going to follow the negative gradient. Because that's the quickest way to get down, isn't it? So if you look at a topographical map with a river on it, you'll see the river always runs perpendicular to the level curves, which is the different heights that you see on a topographical map. You guys with me? In a way that makes sense. Water runs downhill. Ooh, Jeff, that's really ground shape. But now we're talking in terms of the math of this. And look at the shape it has down here. If you look at it, you'll probably guess wrong what shape it is. Actually, you won't, because they tell you right there. So like that. Whee! And it's because of the fact that an ellipse is not symmetric. So it can't just go radially out and hit the side at a right angle. It's got to curve as it goes out. So you can see how it curves as it goes out. This is not a square root though. It actually ends up being a cube. Or cube root if you want to look at it in terms of
So it's always going to go towards the farther radius first.
Yeah, it's going to bend in the direction. I always like to think of it bend away from the major, bend towards the minor, right?
Gotcha.
Okay. I had somebody who got really angry at me almost last semester when I taught this. Why? Why doesn't it just go straight? I'm like, get over it. Because the stupid ellipse is not symmetric. Leave me alone. You guys see that? Okay. All right.
So with a sphere, if you were to make the level curves out of a sphere, how would you know which line to draw? I mean, it's almost like, it's
We
like,
didn't have to be given. I'm not sure how you mean.
it's like you could take just about any path and any path.
No, well, if you had a sphere and you put a ball on the inside, it's going to drop
Okay.
straight down.
Okay, gotcha.
Straight down. It's going to follow
Yeah.
the half of the XY plane would be a straight line. I wish they would have given me that image to play with, but they didn't. That'd be a nice alternative to this. That would look like this in the XY plane, right? Okay, maybe. Okay, cool. Oh. Oh, I already said that. Good. So just to get back to a point from earlier, and I didn't want to get into this too early, because this is what I was talking about earlier. If I have the gradient in 3 dimensions, which should be pretty easy to tell what that's going to do. If the gradient in 2 dimensions, and what does that really mean? If I say the gradient in 2 dimensions, my surface is in 3 dimensions. Because the gradient is all about inputs and what that does. So the gradient, if it's of xy, that means there's a z that it's talking about how it affects that. So the gradient in 2D is just this. So incredibly enough, like I said earlier, in 3D the gradient would be, you can do it, Jeff. No, Jeff, too early. Okay. Right? The weird thing to think about this, though, is it represents 4-dimensional objects. When I said that the gradient must always be orthogonal to the level curves, in 2D, right, the gradient must always be orthogonal to level curves. In 3D, meaning my surface is 4-dimensional, right, because my inputs now are in 3 dimensions, my surface is 4-dimensional,
Normal plane.
which I'm not going to make you draw, so don't freak out. Then it must always be orthogonal to the level.
Plane.
Be more general without going too much dimension. Surface. It must be orthogonal to a level surface. That's kind of freaky. The hell does that mean? So it would be like, I think they have an image I can show you. It's on page, and how important is this really for the math? Not. But they do have one figure that kind of sucks here. Let me see.
What page?
Shoot, they don't have it up here. Page 838. This horrible picture they've chosen. One way to represent a 4D object is sort of like if you had a balloon growing, the 4th dimension would obviously be time. So at t equal to 0, the balloon is like this, at t equal to 1 is like this, at t equal to 2 is like this. So the level surfaces would be the actual balloon at different times. You with me? So that's probably the easiest way, because it's something physical. We can actually take pictures of the stupid balloon at different times and superimpose them, and that would be a 4D object. So the level surfaces, so the gradient must always be orthogonal to the surface itself. Yeah.
Would this be a good 4D object?
Well, not for what I'm talking about. Thank you, though. The color is kind of hard to talk about
That would be the 4th dimension.
being orthogonal to blue.
Oh.
But I appreciate it. That actually sounds like a good band name.
Orthogonal to orange.
Maybe not. All right. So let's do this. Let's try this out. On one side is a quick quiz. On the other side is the, those are, that's my words. On the other side is the practice test. So try out this quick quiz before you go. And then we'll go over the answers real quick. Test is when? Monday's going to be review day.
Quiz get back. I think I'm missing a quiz get back.
Yeah, well, yeah, quiz get back day. Yes.
You hang him out to dry.
Yeah, put an extra one in here.
The quiz question I do by the test, right?
Yes.
I'll do a tester actually.
Yes. So don't forget on test day, homework is due, test 1 corrections will be due. And this quiz that we just took, its corrections will also be due. I can't talk and count.
Did we already?
Yeah, we did. I'm pretty sure we did.
Yeah, Jenny.
Yeah, I was kind of lazy when I made the test 2 and just stole stuff. So that's why the numbering doesn't sometimes work, because I just Frankenstein this together. So just deal with it.
Let's get done.
No, the answer test won't be that long. We talked about 12.5 quick quiz last time, right? We did the answers last time. Did we?
Yeah,
Okay, good.
Okay.
Um,